Hello and welcome to the course on multimedia content delivery in the internet. In this course we will try to get an idea of how big content providers like YouTube, Netflix, Spotify manage to serve millions of users with a good quality of experience and a scalable approach. Delivering content at the internet scale is not easy. There are different challenges involved. The first one is the huge amount of data and huge amount of users. If we consider the first episode of the new season of Game of Thrones in 2019, it had 17 million views just the first day. This means that if you make an approximated computation, that at least 3 petabytes of video was transmitted to users all the same day, which is more or less equal to 3 million gigabytes. If we consider YouTube, 300 hours of video are uploaded every minute by users. And if you consider the catalog of YouTube now, to watch it all, it would take 70,000 years. Okay. Videos also accounts for the biggest part of internet traffic. Cisco predicts that by 2022, 82% of traffic will be video. Another challenge is the quality of experience that users demand. So you have to provide content in a timely way. You don't have to make your users wait, and with a good quality, good resolution, no rebuffering, etc. In this slide, I show you how if the load time of a page goes from 1 second to 3 seconds, the probability of bounce, which is user abandonment, increases by 32%. So this means that if you don't serve content with a good quality to the users, they will just stop watch it. They will choose to watch content for the competitors, and actually you will lose users and you will lose money. Okay, since the advertisements that you will show on your website will be less visible, and so companies will pay you less to show their advertisements in your web page. Okay. So good quality of experience for users mean money for the website provider. Other challenges are the heterogeneity of devices, because users access content by smartphone, tablets, big TVs, etc. And the content should be adapted to each of these. For instance, you cannot send the same video you send to a smartphone to a big TV, because the resolution will be just unsatisfying for users. So you have to treat your content in order to adapt it to all the devices in the market. And this is a complicated process, and we will see how you can do it. Another challenge is that internet network conditions are variable, which may impact the quality of experience for your users, and you will be subject to attacks. Fortunately, together with challenges, content delivery offers also big opportunities. It has been estimated that video on demand market accounts for $17 billion each year, and this is expected to grow every year. This is why there are now big internet actors that made their fortune by delivering content, multimedia content, like YouTube, Netflix, Amazon, etc. These content providers are sometimes called over-the-top services, which means media services provided over the internet, in contrast to traditional TV channels. So this is what we are going to see into this course. First, we will focus on a technology to solve the challenges involved in content delivery. This technology is called content delivery networks, and we will see the mechanisms that make it work. in particular redirection mechanisms, load balancing, and caching strategies. Then we will talk about the video workflow, which means all the processing that a video takes from the moment it has been created, recorded, to the moment it has been consumed by users. Then we will see adaptive video streaming, that is a set of techniques that allow your video client, like the video client in your browser, to consume, to download and to show the video. And we will see what are the elements that impact user quality of experience. Let's now see at high level what are the architectures that can allow large-scale distribution of content. So let's start with the simplest idea. The basic idea, if you are a content provider, suppose you're called MyTube, is that you have your own content, you store them in a server or a cluster of servers, and all the users all over the world need to contact this server and download the content from there. Of course, this cannot work at all because it's impossible. Like, there is no server that can sustain millions of users simultaneously. Okay? So a better approach is distributed, which means that in addition to the origin server, your content should also reside in other replica servers, in other nodes, distributed all over the world, so that your users can download the content from the closest location to them. This implies less latency, obviously, less congestion in the internet, because the traffic remains more or less local to a certain nation, to a certain continent, and doesn't need always to cross the entire internet to reach your users. And also you relieve your origin server from most of the load. Now, how can we implement this distributed approach in the internet? So first, let's see what are the actors of internet. We have on one side users that want to consume content owned by content providers like YouTube, Spotify. And in the middle, we have internet service providers, ISPs, like Vodafone, Orange, etc., that provide the network to transmit the content. Actually, there are different types of ISPs. There are access ISPs and regional and global ISPs. As the word suggests, access networks or access ISPs provide connectivity to the final users or the content providers. Okay, so they let users and content providers to access the internet. But in order to do so, the traffic has to cross regional and global internet service providers, which provide global connectivity. And to do so, access providers have to pay global ISPs for this service. And the more the traffic access networks generate, the more they have to pay to global ISPs. So suppose the users of an access networks on the left are watching a lot of videos of a content provider on the right. Well, you see that for this, a lot of traffic has to be crossing the access networks on the left and on the right. And these access networks have to pay money to global ISPs to let this traffic cross the internet. Okay, so a good idea to distribute content is to reduce this traffic by placing a web proxy. That is a node in the middle in which we can store some of the content, and so that users can download content directly from it. So let's see how a web proxy works. So before talking about the web proxy, let's see how a content is downloaded nowadays. So you have the user accessing the internet through his browser. And the browser sends HTTP GET requests to the server, MyTube server, and the server replies with pieces of content. Okay. Now, if another user requests the same piece of content, again the same transmission must happen. Now, if we put a web proxy in the middle, all the HTTP GET requests pass through the web proxy. Then all the replies also pass through the web proxy. So the web proxy can observe this traffic and can store pieces of content in a local memory called cache. And then the content is served to the users. Now, if another user requests the same content, the web proxy can intercept the request and serve directly the object without generating traffic to the MyTube server. So this was possible in the 90s, and this was a good idea. But nowadays this is not possible anymore, because most of the traffic today is HTTPS, which means that before sending HTTP GET and reply, the user first establishes a TLS channel with MyTube server. Okay, and this TLS channel encrypts all the traffic, so all the HTTP GET and reply are actually encrypted. So if you put a web proxy in the middle, it will just observe a bunch of bytes with no specific meaning. So it will not be able to understand that there is a content request that is being transmitted and that there is a content that is being transmitted. So it cannot store any content and it cannot work at all. So how can we distribute content all over the world if web proxy doesn't work? Well, this is where content delivery networks came out. Content delivery networks, or CDN for brevity, were actually born, we can say, at MIT, when a professor called Tim Berners-Lee, that some call the inventor of the internet, proposed a challenge. That was to provide algorithms or solutions to solve the problem of distributing content in large scale in the internet. Layton and Lewin, that were a professor and a student, worked on this problem and started to provide algorithms in 1996 and to publish them. Then they also started to grow a business. First they got $50,000 in a competition, always at MIT, and in 1 year later they founded a company, Akamai, that is nowadays still one of the biggest actors of the internet. Okay? Then unfortunately the student died in the 9/11 terroristic attacks. Now, how does a CDN work? So suppose you are a content provider called MyTube and you want to use the services of a CDN. So the first thing you should do is to send all your catalog of content to the CDN. This process is called ingestion because the CDN is ingesting your content. Then the CDN is a distributed system made of several nodes across the distributed across the world, and so they will take care of distributing your content to their nodes. So the users will not contact your origin server to get the content, but they will contact the CDN nodes. So in order for this to work, a redirection mechanism must be put in place, because the user doesn't want to deal with the complexity of contacting the CDN, etc. They just want to get their content. So what must happen is that the user contacts MyTube as usual, and transparently there must be a mechanism that redirects the request of the users to the to the best CDN node, and we will see how this redirection is implemented. These three are some examples of CDN companies that provide this kind of service, and these are some of the content providers using CDN's services. For instance, Facebook is not dealing with distributing content themselves, but they pay Akamai to distribute content. Okay, and the same LinkedIn, etc. Actually, what happens is that a content provider usually uses the services of different CDNs in order to have backup solutions ready to work in case one CDN fails. Akamai is still the biggest CDN. Okay, in 2014, 20% of internet traffic was transported by Akamai, and the infrastructure of Akamai is impressive. It consisted in 2014 of 239,000 servers distributed in 139 countries. Okay, and they have a big revenue, etc. These are some of the clients of Akamai. Okay, BMW, BBC, NBC, etc. So again, I want to stress this aspect that BBC deals with creating content. They pay people to create videos, create content, but then they don't have the technical ability to distribute this content to millions of users. So what BBC does is that it pays Akamai, and Akamai will deal with the complexity of distributing content to millions of users. And how do they deal with this? Well, they exploit their distributed infrastructure all over the world. And so they take content from BBC and they put this content in their different nodes. A CDN is a complex system. Actually, a CDN offers different, it is made of different mechanisms and offers different services. Okay, we will see some of them in this course. So